In episode 46, Analyze Test Results and Track Defects Rigorously, we concentrate on what happens after the tests finish running and the reports land on someone's desk. Raw findings, whether from tools or human testers, only have value if they are translated into decisions and sustained follow-through. That translation is not automatic. It depends on disciplined analysis, careful consolidation, and a tracking process that survives busy release cycles and shifting priorities. When you approach test results with this level of rigor, you turn a mass of alerts and screenshots into a structured view of risk, commitments, and progress. The first practical step is to consolidate outputs from every source methodically so that you are not making decisions in silos. Dynamic scans, static analysis, dependency checks, penetration tests, fuzzing campaigns, exploratory test notes, and incident investigations can all produce findings that touch the same systems. Pulling these streams into a common repository with at least a shared concept of application, environment, and date allows you to see overlaps and contradictions. It also helps you recognize where one tool is strong and another is weak, because you can compare the types of issues each tends to surface. This consolidation transforms scattered evidence into a single picture that can be reviewed with stakeholders. Once findings share a common home, the next move is to normalize severities instead of accepting every tool's grading at face value. Different scanners and services use their own scales and labels, which can create confusion when one calls an issue critical and another calls the same pattern medium. A disciplined program defines clear criteria for critical, high, medium, and low, grounded in impact, exposure, and regulatory implications rather than vendor defaults. You can still preserve the original score from each tool, but you map it into your standardized categories for reporting and decision-making. Over time, this normalization builds trust that severity actually means the same thing across teams and technologies. Duplicate findings are almost inevitable once multiple tools and testers look at the same systems, so deduplication is a necessary investment. The goal is not simply to delete similar-looking issues, but to correlate symptoms and decide when they point to a single root cause. Two different endpoints might expose the same vulnerable library, or a dynamic scan and a penetration test might both highlight the same injection weakness from different angles. By analyzing parameters such as location, affected components, and exploit behavior, you can group related items into clusters driven by one underlying defect. This clustering reduces noise in dashboards and helps remediation work focus on structural fixes instead of scattered patches. To support serious remediation and later verification, each defect needs a level of detail that allows others to reproduce it. That means capturing the environment where the issue was observed, including application version, configuration context, and relevant infrastructure details. You also record the data sets used, such as specific inputs or sequences of actions, and describe clearly what the tester expected to see and what actually occurred. When reproduction steps are clear and complete, developers and other testers do not waste time guessing about subtle conditions. This clarity is especially valuable during assessments where you may need to demonstrate how a weakness was discovered and why it matters. Ownership and scheduling information are just as critical as technical detail because they determine whether anything gets done. For each defect, you should record who owns it, when it is due, and what other work it depends on. Some issues will block others. For example, when a shared platform problem must be addressed before individual applications can fully remediate. Capturing these relationships allows you to see where a single unresolved item is preventing progress on multiple fronts. When this structure is visible in your tracking system, discussions about status move away from stories and toward traceable commitments. Linking defects to requirements, threats and controls gives you the ability to talk about risk reduction in a traceable way. This linkage also supports evidence needs during assessments, where you may need to show how tests verify that controls work as designed. When done consistently, it turns your defect list into a structured view of control health. Prioritization then becomes a matter of grounded judgment rather than guesswork. You evaluate remediation order using factors such as user impact, practical exploitability, exposure time, and the business risk associated with affected systems. An issue on a rarely used internal tool may be less urgent than a similar issue on an internet-facing payment interface, even if the technical pattern is identical. Likewise, a vulnerability that has been present for years may deserve special scrutiny because its long exposure increases the chance that it has already been discovered externally. By expressing these considerations clearly, you enable leadership and product teams to understand why certain items move ahead of others in the queue. Validating fixes closes the loop and prevents your tracking system from becoming an archive of assumptions. For each resolved defect, you plan targeted retests that check not only the exact scenario originally reported, but also nearby behaviors that could be affected. Guardrail checks, such as confirming that a new access control rule does not break legitimate usage, are important for maintaining system usability. Automated regression suites can be updated to include cases derived from fixed vulnerabilities, ensuring that the same pattern is tested in future releases. When this verification is recorded alongside the defect, you have a clear trail from detection through to confirmed resolution. Tracking trends over time is the next layer of discipline, because individual defect stories do not show whether the overall situation is improving. Metrics such as escape rate, which measures how many defects are discovered late compared to early, and reopen rate, which shows how often fixes fail, give insight into process quality. Mean time to remediate across releases highlights whether teams are becoming faster and more predictable in addressing issues of different severities. These trends can be viewed by application, by team, or by control area, depending on the questions you want to answer. When reported regularly, they turn defect tracking into a feedback mechanism for the entire development and security lifecycle. As you observe these trends, systemic patterns often emerge that call for platform or process changes rather than repeated one-off fixes. You might notice that a particular library or framework is associated with recurring vulnerabilities, suggesting that a secure wrapper or centralized pattern is needed. Or you may see that a certain stage of deployment consistently introduces configuration drift, indicating that automation or additional checks would pay dividends. Proposing improvements at this level shifts the conversation from chasing individual defects to strengthening the environment in ways that prevent whole classes of problems. This is where defect analysis becomes a powerful driver of architectural and procedural maturity. None of this work has much impact if it stays buried in tools that only a handful of specialists read, so communication is crucial. Concise narratives help contextualize dashboards, telling stakeholders what the numbers mean and which actions are most important in the near term. Dashboards themselves should highlight both current status and trajectories, with clear signals when thresholds are breached. Exception alerts, used sparingly, can draw attention to situations where risk is changing rapidly, such as a sudden spike in high-severity findings on a critical service. By shaping the information this way, you enable busy decision-makers to grasp and act on defect data without drowning in detail. A brief mental review of this episode's themes shows a coherent chain from raw results to meaningful change. You start by consolidating findings from all sources and normalizing severities so everyone speaks the same language. You then deduplicate and correlate issues, capture reproduction detail, and assign ownership with realistic dates and dependencies. Linking defects to requirements and threats makes risk reduction visible, while prioritization and verification ensure that effort is spent where it matters most. Trend analysis, systemic improvements, and clear communication complete the picture, turning defect tracking into an engine for continuous improvement rather than a static ledger. The practical conclusion for episode 46 is to ground these ideas in a single, concrete action. Choosing one open defect and documenting reproducible evidence clearly, with environment details, expectations, and observed behavior, immediately improves its chances of being resolved correctly. From there, you can link it to the relevant requirement or control, assign an accountable owner, and record a realistic due date that fits with other dependencies. Even this small exercise demonstrates how discipline in analysis and tracking changes the trajectory of an issue. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.